Hi students, I am Jagdish Pupala, MSc MPhil. I am associated with Narayana Educational Institutions, Narayana IIT Academy from past 15 years. Hi students, in wave motion, we are going to discuss about, these are the subtopics. One, after having some brief introduction, we need to go through the traveling wave or the progressive wave, and then the types of progressive waves like transverse and longitudinal wave parts. We need to distinguish them, and we need to discuss about the properties of it, and then to describe mathematically, we need to derive the relation of displacement of the particles from the mean position in the case of a progressive wave, which describes each and everything of it mathematically. And the terms involved in this displacement relation is to be elaborately discussed so that we can understand each and every term and its uniqueness. The speed of the traveling wave equation to be derived so that the factors influencing the speed of that traveling wave can be understood. And another important principle of superposition of waves, so that due to the mixing of the waves when they are traveling through the same region of space, what will be the resultant effect to be discussed, and the reflection of waves when the wave is traveling in a medium obstructed, or it is passing from one medium to another medium, then there is a possibility of getting back into the same medium. That is reflection of waves. As a result of superposition of incident and reflected waves, standing waves will be formed or stationary waves will be formed. We need to discuss about the stationary waves formation in the case of transverse waves as well as longitudinal waves. And in the case of longitudinal waves, that too, principle of superposition if you apply, will come across that sounding effect getting maxima and minima due to the slight difference in the frequencies, which we call it as beats, and due to the relative motion between the source and observers, the way the frequency received will be modified, can be studied. The name Doppler effect. Wave motion is a kind of disturbance created in a medium, and it's a kind of energy in transition. So coming to the term wave, in physics, fundamentally the definition of physics, if you verify, there we will study about different types of states of matter and their properties, that means solids, liquids, gases. So we'll talk about different forms of energies existing and how these energies were transformed from one form to another form. And as we know, this energy also will be transferred from one point to another point. That means now we are communicating. That means my energy is being generated in the form of sound so that I can communicate. So here that sound is a form of energy. Sound is a form of energy. And if you come across our ancient history and everything, everybody said the way of transferring energy or receiving energy is through chanting or through some kind of magical words like. So sound is a kind of energy and which is being transmitted from one point to another point. That means it is directly you are hearing something, means it is transfer of that energy from one source to your eardrum. So here the way that energy is transmitted is nothing but called wave motion. So it's a kind of energy given or delivered into surrounding medium which is being transmitted. So we can say wave is nothing but a disturbance created in the surrounding medium of it, and hence we can say energy which is being transmitted. So wave is simply energy in transition. So here this wave, the way that energy can be transmitted will be taking place with the help of the surrounding medium, or some cases like the energy received from the sun directly, that which is the energy source for us humankind. So here light is another form of energy which we understand later as an electromagnetic wave. So here the wave, the energy transmission is taking place in different ways. So hence we classified them like a mechanical wave where it requires a medium for its propagation. A material medium is required. That's why we are saying it is mechanical. Since energy is being transmitted by applying some force on the medium particles, hence it is said to be mechanical wave. If it do not require any mechanical medium, that means simply vacuum is there, but energy is being transmitted. How it can be? That can be done by having continuously fluctuating electric and magnetic fields. That means, correctly speaking, time varying electric and magnetic fields releases or loses energy and will be transmitted without taking the help of the medium, which you call it as electromagnetic wave. There is some another kind of wave also will come across, but actually this is not a kind of we can say a mechanical wave or electromagnetic wave. That means directly a kind of energy form. But in quantum mechanical expressions, when the particle is in motion, a particle is in motion simply as we come across mass and energy conversions at higher level introduced by great Einstein based on his E is equals to mc square. We know that mass is being converted into energy and energy is being converted into mass. They are interconvertible. So when mass is in movement, that means it has some linear momentum, then somehow part of energy will be appearing in the form of a wave associated with that particle, which we call it as a matter wave. So whenever a particle is in motion, it is always associated with a wave known as a matter wave. So understanding it a bit complex for us for +1 and +2 level. So we'll confine ourselves to the mechanical wave, to the core, whereas you will get the electromagnetic wave insight after finishing electricity and magnetism and after understanding electromagnetic induction principles too. So here in a mechanical wave generation, if you talk about, that means here speech through a mic is different. It is just normal generation of word in the surrounding air medium is nothing but creation of mechanical wave. Speech is different. That means where there is a conversion of energies. That means sound converted into pulses, electromagnetic pulses through microphone, and it will be amplified and again processed to remove the noise, and again it is regenerated through another amplifier simply. So that a sound will be amplified and you are getting different types of conversions, and again you are getting it in the form of sound. Here we are talking about direct communication, that is direct person to person communication. Then the generation of sound is nothing but creating a mechanical wave in the surrounding air medium. If air medium is not there, no any kind of air or any kind of gas, vacuum, can we send this energy created by our vocal cord? Whatever you will shout, can it be transmitted? Means no, it cannot be transmitted. That's why we are naming this one as mechanical wave. So here we are just creating a disturbance in the surrounding medium by applying some force and hence transmitting energy to it. So that medium, whatever it is existing, must be a mechanical one, like solids, liquids and gases, which are having some kind of elastic behavior for them, so that particles can vibrate and they must have some inertia of regaining their original position. And if less resistance is offered, it can be transmitted to large distances. If not, however I shout, it can be reached just few students. As distance increases, gradually energy will be attenuated, that means going to decrease. So a mechanical wave needs a medium for its propagation with these qualities. Now, how this energy can be transmitted in a medium in a different ways? Like energy is endlessly, if it is having less resistance, endlessly it is propagating. I'll call it as a progressive wave. That means wave generated at one point will never return back to the source, means it is not coming back, always it is forwarding. So it is a traveling wave. So energy is continuously advanced. No sir, in a closed region, if that energy is bounded due to reflection or by some means, then energy is said to be bounded in that region. We'll call it as a stationary wave. That means energy is trapped, is not being transmitted. So whatever the medium we had, in that medium particles itself, the energy will be distributed and it will be sustained. If there is no any attenuation in it, then it can sustain for long. If there is some resistance in the medium, particles movement, then I can say the energy is being attenuated. Now in the traveling wave, we said it is taking the help of the medium to transmit the energy. So here, how the medium is getting involved to transmit the energy? If you take the surface of stagnated water and a drop, if you just allow it to fall into it, that means you are creating a disturbance in it. Then you can find some ripples were generated on the surface of it. If you observe these ripples, it is simply carrying the disturbance. If you place a small pepper Titanic on it, it appears to be moving up and down. Whenever ripple crosses it, it just moves up and down, but it will not be moving along the ripple. That means when a disturbance is carried from one point to another point, by taking the help of the water here, but water particles are just, surface water particles are just appears to be moving up and down, but not being transmitted from one point to another point. So here particles are just moving to and fro about their main position, but not getting transmitted from one point to another point. So here, if you consider the medium particles movement, here, if the particles are vibrating perpendicular to direction of propagation of the wave, perpendicular to direction of propagation of the wave, it is what you call a transverse wave. If the particles are vibrating parallel to the direction of propagation of the wave, we will call it as a longitudinal wave. So this is how we can discriminate the two ways of propagation of this progressive wave, where the energy is being continuously transmitted. So we need to describe these two, we need to distinguish these two, and we need to distinguish these two, and we need to have the mathematical insight about each and every part of it, so that we can study them and we can just analyze the applications of them mathematically. In mechanical waves, we got progressive waves, stationary waves. I just want to distinguish briefly. Coming to this, energy is being continuously advanced, whereas in the case of stationary waves, it is bounded. And if you study the basic structure of them, we'll come across formation of crusts and troughs, or compressions and rarefactions in the case of progressive waves, whereas in the case of stationary waves, nodes and antinodes will be formed. That means here this structure is identified like a kind of reflections, whereas in this case, crusts and troughs and compressions and rarefactions. If you consider any two particles of this wave, continuously advancing wave if you consider, continuously advancing wave if you consider, any two particles of them if you consider, they will not be in phase, they are out of phase, you can say. They will not be in same phase. That means state of vibration of the particles will be different. One particle state of vibration is different from another. In this progressive wave, we will come across another two types of it, because when wave is advancing, the particles of the medium only will vibrate, we discussed. So in the progressive wave, we got transverse wave and longitudinal wave, two types. Here energy will be advanced continuously, but vibration of the medium particles, if you study, in this case the particles will vibrate perpendicular to the direction of propagation of the wave, whereas in this case parallel to the direction of propagation of the wave. Here in this case clearly crusts and troughs will be formed. That means here like this, crust, trough, like that. Whereas in this case compressions and rarefactions will be formed. Coming to this, like this, in a region there will be compression and rarefaction, like that. The particles are vibrating parallel to that self. Pressure is maximum, pressure is minimum. Like pressure is maximum at compression, pressure is minimum at rarefaction. Like that, it will be propagated. Crust to crust or trough to trough distance is what you call lambda, wavelength of it. Whereas here, compression to compression, rarefaction to rarefaction. These transverse waves can be created only in solids. Why? Because here that medium needs a kind of elastic behavior. So in solids, they can sustain with that shear stress. That's why transverse waves can be created only in solids. Whereas if you consider liquids and gases, that means fluids, they cannot sustain with the shear stress. This starts moving action. That's why it's not possible to create transverse waves in fluids. Whereas in the case of longitudinal waves, particles will vibrate parallel to the direction of propagation of the wave. That can be possible to create in solids, liquids and gases. So examples for this one is waves on strings, whereas example for this longitudinal waves is sound waves. Here, if a disturbance created in a medium is considered, let us take, it is created for a short duration, then we will call it as a wave pulse. Here, if it is continuously generated, means you can say that it is a wave motion, wave simply. So pulse, short duration, wave used for continuous transmission of it. So if you come across this pulse, here in this case, the displacement of the particles here can be taken as a function of the position from the origin where it is created and the time. So y's of x comma t will be a function of x minus vt, we will say. This pulse can be of any shape. We need to discuss about this one in detail. So this wave pulse can be of any kind of shape, just like heartbeat for short duration is an example for pulse. Otherwise it can be a kind of circular pulse created on the surface of any water, or any kind of sinusoidal wave created on the surface of the water. These are the examples for this wave pulse. Here the wave pulse, mathematical representation of this wave pulse, which is depending on the position at a time, can be taken like this to represent such a type of shape of the pulse, a by b plus x minus vt. Here in this case, this negative sign indicates that in a by b plus x minus vt whole square, which is y of x comma t, indicates that this wave is propagating along positive x direction. Positive x direction, that it is propagating like this in this positive x direction, and its amplitude of it will be given as the maximum displacement from the mean position is what you call a by b at t is equals to 0, you can say. So if you take this one exactly, it would be like this. So amplitude is equals to a by b, we will say. So here it can be of any kind of shape. If you take this one is an example for a kind of pulse created like this. Okay, so about the origin, if you consider, it would be like this, plus or minus a, it is defined. Apart from that, it is 0, it is. So here in this case, it is a hemispherical shaped. Plane wave, if you consider, means cross section of it, if you verify, it will be semicircular shaped wave pulse. So this is short duration of a wave, which you call it as pulse, and it's a mathematical notation of it. So coming to this wave, which is also a function of x and t, it can be of any kind of shape. Depending on that, we had sinusoidal waves and non-sinusoidal waves. That means it can be of this kind of shape like this, or it can be a kind of shape like this, sawtooth wave like. So it's a non-sinusoidal wave. But here most of the times we will confine ourselves to plane waves. We will consider plane waves only. So this is a string is fixed at one end and it is disturbed. So you will get a transverse wave on it, which can be generated and continuously advanced up to this extent. Whereas this one is air or fluidic like. So this piston is vibrating so that it can create a kind of longitudinal waves in it, which is a continuous wave. So here, to describe the displacement of this disturbance after some time t, we'll consider the function of x minus vt gives that wave advancing in positive x direction. If you take plus, it should be taken that it is moving along negative x direction. So general expression for the displacement wave, displacement of the particles of the medium when wave is propagating, is a sine of kx minus omega t plus phi, or it can also be expressed as sum of two expressions, sinusoidal harmonic functions, simply a sine kx